What is going on, guys? Welcome back. In today's video we're going to build an intelligent voice assistant in Python that reacts to a wake word. So it's not going to process any of the sound unless we call its name, and we can decide what its name is going to be. So let us get right into it.
It's not a game, it's a rich thing.
Alright, so before we start with the coding and the implementation, I want to show you what we're going to end up with. I'm going to run the script here in a second, and it's going to open up a graphical user interface with a little bot icon, and the bot icon is going to be black. Black meaning that it's inactive, it's not listening to commands, it's just waiting for the wake word. Then when I say the wake word, which is in this case going to be hey Jake, because I called this bot Jake, it's going to turn red, and then it's going to process the voice command. So I'm going to run that here. I'm not going to talk too much while doing that. I'm going to try to do some basic commands so that you can see that nothing is processed, and then I'm going to say hey Jake to show you that it's going to process the commands afterwards. So I'm going to run this now. It's going to train a neural network, and then I'm going to start showing you what it's going to do. Test. What is Neural 9? Hey Jake. What is Neural 9?
Neural 9 is a YouTube channel and an online brand, which focuses on programming, machine learning, and data science.
And now it's inactive again, as you can see. So this is what we're going to build, and we can customize whatever this voice assistant is capable of doing by providing a JSON file. We're going to talk about this here in a second, but this is the JSON file of the sample that I showed you. So this is what we use just right now. So we had the tag neural 9. I asked what is neural 9. It doesn't have to be the exact static sentence that is provided here. We're providing some sample sentences, and then the bot is capable of also recognizing sentences and categorizing sentences or commands or requests that are similar to those here. So here we have what is neural 9, tell me about neural 9, and so on. But if I asked something about, I want to know what neural 9 is, it is still going to answer with this response here. So this is what we're going to build. This was just a little preview to motivate you for the project. All right, so let us now move on to the implementation part. And for this video today, we're going to rely on 3 external modules / libraries, which are going to allow us to implement the functionality that we need. And for that, we're going to open up the command line, and we're going to start by installing the speech recognition module. And this module will obviously take our speech, our raw audio data, and turn it into text so that we can use it in the model. Then we're going to need the model itself. So we're going to install Neural Intents, which is a library that I have written myself. It makes it very easy for you to create assistants, text-based assistants. And then we're going to need the output from the model. So when we get the response, it's going to be a text response, but we want to have an audio response. So we're also going to say pip install PyTTSX3, which is Py text-to-speech for version 3, and this is going to allow us to take the text and turn it into speech so that we can hear the assistant. Once we have that, we're going to import sys, we're going to import threading, we're going to import tkinter, which is the GUI that we're going to use, as tk, and then we're going to import the external modules. We're going to say import speech underscore recognition, and we're going to say import PyTTSX3 STTS. And then finally from neural intents, we're going to import the generic assistant. This is what we're going to use, and this generic assistant works with a so-called intents file. So we're going to create a new JSON file here, and this JSON file will now determine what kind of requests the bot will be able to handle, the assistant will be able to handle. So we're going to call this intents.json, and the structure is actually quite simple. We have some curly brackets, and then we have the intents. This is a string, the intents object here, or the intents key. And this is going to be a list of more dictionaries here. And we're going to say that each intent will have a tag, so a name basically. And we can say, for example, one will be the greeting intent. And for each intent, we're going to provide samples. Those are called patterns. So we're going to say patterns. And in the patterns, we have a collection of patterns. Those are just strings. So one for a greeting could be hi. Another one could be hey. Another one could be what's up? Question mark. Another one would be hey, how are you doing? Whatever. You provide a couple of intents, and then what the model is going to be able to do is it's going to take all these patterns as sample data, and if you say something that's similar to that, it's also going to recognize it as a greeting. So if you have, for example, something like hello, what's up? It's still going to recognize this as a greeting. Even if it's not exactly what's up, you can say hello, how is it going? And it's going to recognize this here also as a greeting pattern, unless you have some very similar patterns. For example, maybe something like how are you? And then it's going to confuse what's up with how are you or something like that, depending on how many tags you have or how similar tags you have. But the response is going to be static. So it's going to be flexible with the input. It's not going to be flexible with the response. The response is going to be the same, or at least it's going to be a collection of responses. So you can say responses and then you pass a collection, and you can have multiple responses, but it's going to take a static response. It's not going to learn how to formulate responses based on the samples here. So it would be something like, hey, sir, or what can I do for you? Something like that. So you can provide many of those. It's going to pick one randomly, but it's not going to generate new ones based on the input here. And then once you have this intent, you add a comma and you add another intent. And you can design your own intent file. You can say greeting, you can say, I don't know, weather, you can say stock price, whatever you want to have here. You can also later on with a generic assistant, you can bind a tag to a function. So you don't have to just work with the response here. You can also say, I don't care about the response. When I get a specific tag, for example, stock price, I want to open up a stock API or something like that. So you can connect the tag also to a functionality. You don't have to connect it just to an output here. Based on all that, I have created an intent file for this video. You can, as I said, create your own file. I'm not going to provide this one because it's just a sample file. You can design your own however you want. The structure I explained already. And here we have a greeting intent. We have a neural 9 intent asking essentially what neural 9 is. Tell me about neural 9. And then we have a name intent. What's your name? It's going to be Jake in this case. And last but not least, we're going to have the file intent, which is just to show you that we can connect a tag to a functionality. So we're going to be able to create a file, and you can see the responses are empty because we don't need responses in this case. So once we have this file here, which we now created, we're going to continue with the code, and we're going to create a class for our assistant. We're going to say class assistant, and this assistant will have a simple init method here, a constructor, and we're going to say that it has a self.recognizer, and this recognizer is going to recognize the sound, so it's going to be speech recognition.recognizer. This is going to be the instance. We're going to say self.speaker will be TTS init. This will be the voice of the assistant, basically. And we're going to say self.speaker.set property, and we're going to set the rate here to 150. Once we have that, we're going to create our assistant. We're going to create the generic assistant. So this is going to be the constructor. And basically what we can pass here, as you can see, we have the intents, methods, and we have the model name if needed, if we want to save and load the model, which we're not going to do in this video. But I can just provide here now intents.json, and this is going to load the intents file and be already trained and everything. I mean, we have to call the train method, but you have to do nothing in terms of machine learning logic. You don't have to think about how to turn words into numbers and then feed them into the neural network in a scaled way or something. All of this is done by neural intents. You just have to pass the JSON file with the correct key names. And then what we do is we say intent_methods, and this is going to be a dictionary, and this dictionary will map a tag to a function. And we had a function, we had a tag called file, this one. We want to map that to a function, so we're going to say file will be mapped to self.create_file. We're not calling the function, we're just passing it. And since we don't have the function yet, I'm going to create it down here. I'm going to say create file, and I'm going to pass for now, so I'm just going to keep this function here. Essentially, this means that if the tag is not file, it's going to just give us one of the responses that we have here. So in this case, we always only have, here we have 2 responses. We're going to get one of the responses. If we get file, we're not going to get one of the responses. We're going to call the self.createFile function, and here we're going to do whatever we want to do. So that is that. Then we're going to say self-assistant.trainModel to actually make this work. And then we're going to say, then we're going to implement the graphical user interface. And for that, we're going to say self.root is going to be tk.tk with a capital T. And then self.label is going to be a self. It's actually not going to be self. It's going to be tk.label. And the text is going to be an icon. Now you can choose whatever you want. I picked the robot emoji, so you can just Google robot emoji and then you're going to be able to type it here as a Unicode character. You can also just use, I don't know, an F character, or you can use a star character, or you can use whatever emoji you want, or you can, if you want, also load an image. I just pick this icon here, and then we're going to say the font is going to be equal to Arial 120 bold to make this larger, and then self.label.pack. And then finally, we're going to say self.root.main loop. But before that, because this will then start the main loop, we want to have a separate thread that listens for the audio, because this main thread is now going to handle the graphical user interface, but we want to have another thread that is listening for our voice commands. So we're going to say now threading.thread, and then we're going to say the target is going to be self.run_assistant, and the argument, we don't need arguments. I'm going to say start afterwards. So this is going to take this function here that we don't have yet. So I'm going to create it, self.runAssistant. This function is going to be called in a separate thread. So this is going to run all the time while also running the GUI in another thread, right? So that is the logic, and the logic is going to be the following. While true, so in an endless loop, we're going to try the following. We're going to say with speech recognition dot microphone as mic. We're going to say that the self recognizer that we created before, we're going to say adjust for ambient noise with the microphone, and the duration is going to be 0.2. So this is the duration that we allow for silence, essentially. And then audio equals self.recognizer.listen mic. This is going to get the audio from the microphone, and then we need to turn this audio into text. So we're going to say text equals self.recognizer.recognize via Google. So recognize Google, the audio, and then we're going to say text equals text.lower to make things less confusing for the model. And then what we do is we say if what was set in the text, in the audio, if that is, or if that contains hey Jake, then we're going to activate. Every other case will be not activated. So if we say anything that does not contain hey Jake, we're not going to process anything. If we hear hey Jake, then we're going to process the commands afterwards. So we're going to say, if that is the case, self-label, the config will be, we're going to change the config so that the color is now red. And we're going to wait for another input. So we're going to run another audio instance in here in this if case so that we can execute it. So we're going to say audio is again self.recognizer.listen microphone, and then we're going to turn this again into text. So text self recognizer, recognize Google, audio, and then text is going to be text dot lower. And I actually made a mistake here. We don't use lower to not confuse the model. Here we use lower so that we can just look for hey Jake in lowercase. Here we now use text lower to not confuse the model. And also to check if the text is equal to a stop word. So we're going to say if the text is stop, then we're going to stop. We're going to say, okay, self.speaker.say. This is the output, the voice output of our assistant. We're going to say bye. Then we're going to say self-speaker run and wait to actually hear the bye. And then self.speaker.stop, self.root.destroy, sys.exit 0. Or actually just exit, doesn't really matter. Otherwise, if the word is not stop, if what we said is not stop, then it's going to actually feed it into the model and get a response or execute a respective function. So we're going to say if text is not none, this is also an important case. Then we're going to say the response is going to be self-assistant, and we're going to request from the assistant a response or an action, and we're going to say that the input for that is the text itself. If the response is now none, we're going to say self.speaker.say self.speaker this is if response is not none. If the response is not none, then we're going to say whatever the assistant is saying. So we're going to say self-assistant dot actually, we don't need to ask it twice. We can just get the response here. Say response, and otherwise, we actually don't need an else branch. So again, let's recap because I was confused at 2 points here. Again, we take the text from the audio. So we take the microphone, we listen, we get the audio, we turn it into text. If the text contains "Hey Jake," then we turn the label to red to see it's active. We ask for another audio input. We turn that into text. We turn that into lowercase. If the text is stop, so if we set stop, the model is going to, or the whole program is going to shut down. It's going to say bye. It's going to destroy everything and exit. Otherwise, if the input was not stop, we're going to check if the text is none. If the text is not none, we're going to continue. We're going to ask the assistant for a response. If there is a response, so if we're not just using something that has a function, if there is a response, we're going to output that response via the speakers, and otherwise we're not going to do anything because the model is already, by calling the request method, is going to call the function that we passed in the dictionary here, so self.createFile. So self.speaker run and wait, and then self.config self.label.config is going to be foreground color set to black again, because now we're inactive again, and actually we need to do that here in all cases actually. I mean, here it doesn't really matter, so we can leave it like that. That is that. And then all we need to do is we need to call an except for the try. So here we're going to say except. If we have some problems, we're just going to say continue, and that's it. And we're also going to deactivate. So we're going to take the self-label config here, which turns the logo or the icon to black. And we're going to do this here as well. So if for some reason the model crashes or the speech recognition crashes, we're going to just have to say, "Hey Jake," again. And then finally, let me just implement here the create file with open some file.txt in writing mode as f write hello world, just so we see that the function is being called. And then all we need to do now is create an instance of the assistant. And that should be enough to get it started. So we're going to run this now, and then I'm going to try if this works. Test. Hey Jake, what is Neural 9?
Neural 9 is a YouTube channel and an online brand, which focuses on programming, machine learning, and data science.
Hey Jake, create a file. Hey Jake, stop.
Bye.
There you go. So it created the file here, hello world. It said bye, it terminated, and yeah, basically it works. So this is how you build a simple voice assistant that works with a wake word and a graphical user interface in Python. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.